commercial vehicle pistons, designed for efficiency. Pistons are a key component within an internal combustion engine, transferring the release of fuel energy into mechanical motion. Although nearly everyone has heard of a piston, and most people understand the basics of how they move, many will be unaware of the different features of a piston and what they do. What's more, they may not appreciate that if pistons are continued to function correctly, the critical role which innovative commercial vehicle engine lubricants play is a significant factor too. Pistons have 3 grooves for piston rings to fit into. The top compression ring, along with the engine lubricant, provides a seal between the piston and the cylinder to ensure maximum energy from fuel combustion is converted into motive power. The second ring provides additional sealing and scrapes excess oil from the cylinder liner wall as the piston moves down to minimize oil entry into the combustion chamber. The third ring is designed to help distribute the oil around the full diameter of the cylinder. In modern piston designs, the oil arrives at this piston ring through holes and passages within the piston itself. Piston ring areas are highly susceptible to deposit formation, especially if poor quality lubricants and, to a lesser extent, poor quality fuels are used. The area above the top piston ring is called the crown land. This land is exposed to high temperatures and pressures and can become coated in deposits after extended usage. Keeping all areas of the piston clean is necessary to ensure a vehicle's performance is not compromised. Between the top and middle piston rings, you'll find an area called the second land, providing stability to the piston rings either side. Below the second ring, you will find the third land, which also exists to confine the piston rings. The piston skirt is the large area at the front and rear of the piston. This is designed to stabilize the piston as it moves up and down in the cylinder to reduce any rocking motion of the piston, which would reduce efficiency and accelerate cylinder wear. The top of the piston is called the piston crown, and the highest point is called the piston head. Some pistons have features in their design to allow close timing of the piston movement and valve movement. This piston, however, features a slight recess from the piston head called engine retardation relief. This allows for a type of efficient engine braking to be used, normally for long sections of downhill driving. The combustion bowl is an area of the piston designed to aid the mixing of fuel and air during combustion. It also helps convert energy from combustion into the maximum amount of downwards force. Pistons are no longer solid objects. They have holes and passageways to help the oil circulate to the areas that need lubricating. Oil feed holes allow lubricant to pass from inside the piston through to the third piston ring to lubricate the cylinder wall. Oil drain passages help excess oil drain back into the crankcase more easily, and the piston boss is a reinforced area of the piston skirt that keeps the gudgeon pin in place. Underneath the piston, you can see where the oil drain passages feed the surplus oil to. The undercrown gets exceptionally hot as it sits the other side of the combustion bowl and has to absorb and dissipate significant heat energy. Pistons can be made from a variety of materials, namely aluminium alloys and combinations of aluminium and steel. The majority of all new diesel engines use steel. This piston is made from 2 different grades of steel that have been friction welded together for optimized cooling gallery design and ring belt rigidity. The weld line can be clearly seen. Finally, you can see a piston cooling gallery oil hole sitting directly above a piston spray jet, which sprays oil up through this hole to cool a cavity within the piston. This cavity allows the oil to circulate within the piston to help dissipate heat from the piston head and directs the oil through the oil feed holes to the third piston ring. Using inferior quality engine lubricants can lead to deposit formation in the cavities and the undercrown, often resulting in the scorching or cracking of the piston. Each characteristic of a piston has been carefully considered and engineered. Today's modern pistons are a result of many decades of design evolution to deliver engine efficiency. At the same time, engine lubricants have also improved and advanced to help enable this hardware development. For pistons to operate efficiently and to maintain cleanliness, the use of the correctly formulated and original engine manufacturer (OEM-approved) lubricants is essential to minimize the accumulation of harmful deposits and excessive wear which impede performance. Appropriate lubricants play a vital role in the commercial vehicle market drive to reduce emissions, increase fuel efficiency, and improve engine durability.